Thanks for Professor Liu's introduction. It's helpful for us to understand the features and the benefits of the CFFR system. I think there are some questions in the studio, so we can help them to answer the questions.
Thank you, Professor Liu. Anybody?
Thank you.
Yes. Yes, Hashino-san.
Can you hear me?
Yes.
Thank you. This is Kakuta from Japan. Thank you for nice and wonderful presentation. I would like to ask a few questions. First, I just saw that in the slide that you can estimate the flow velocity and FFR by computational flow dynamics, and you can get the distal coronary pressure, right?
Yes.
Is it just resting flow velocity, or you can estimate hyperemic flow velocity? Which do you estimate?
They can use aorta pressure and distal vessel pressure and compare with the TIMI frame account. So they just automatically to computerized this the parameter. So it's not real to measurement. Just use the TIMI frame account.
For resting angio, you can use frame count from resting angio.
Yes.
But you can estimate FFR, which means you can get the hyperemic flow velocity, right? What? Just resting flow velocity. Which one do you estimate? Resting. Mm-hmm. I think you can also estimate hyperemic flow velocity.
Mm-hmm.
I'm saying this because I saw in your slide that you can get the IMR also by your computational algorithm. IMR is a hyperemic index. So I thought that you can get resting and also hyperemic flow velocity. Am I wrong?
No, that's correct.
No,
that's correct.
That's correct.
Yes.
Yes. I think this is more engineering questions. Professor Liu is from the clinical views. Just in addition, sorry, Professor Liu, to cut short of this question.
No
So yes, you're right that the flash angio CAFFR is based on the resting state, but it is not actually a resting state. It's based on the contrast state. So that the pressure under the contrast is slightly different than the resting state and slightly different than the hyperemia state. So it is something like in between. We make up analysis and the regression so that we make a linear regression to the resting state, as you said, that we can use our aortic pressure sensors and TIMI count and the contrast view from different perspective, and to reconstruct it, the FFR, IFR, and IMR. So based on the same view and the same input.
Okay. I understand. Thank you.
No, thank you, Hoshino-san. I see that in the dialogues that in the input, let me see. Mr. Brood Jorwasek asked a few questions. Should I speak it out? So one is that, has a study been made, or is it in progress comparing FFR or CFFR in bifurcation lesion in the main and the side branch? Second question is, what about osteo and the LM lesion? Barut, is this the question addressed to Professor Liu?
Yes, From
Okay, thank you.
the case we showed in the presentation, we can measure bifurcation lesion by set branch and the mean vessel separately. So the answer to the bifurcation lesion is we can do. For the left mean lead lesion, I think left mean lead lesion sometimes is different from the other position of the vessel. So if you have solid only left mean lesion or left mean combined with RAD or circumflex, I think it's different. So if you have multivessel disease, maybe influence the measurement for for the left mean. So if you have only have the osteo of the middle portion of our left mean, so use CFFR, I think is correct.
Yes.
My answer is okay.
Yes, Borut, if your question is about the size study of the flash study that we conducted in the 320 patients, the answer is that we have not specifically summarized because it's not part of the endpoint and it's part of the study. But I think it would be interesting to do some size study based on the clinical cases in the front. But we do have some left main lesions study. Now we are working with Malaysian doctors, Alam Fong. So because we use it to prioritize and segmented different lesions, LM lesions in the side. So I think that would be interesting point. Yeah, thank you. Okay. Is that okay, Borut? So I'll go to the another question then, if that's okay. Yes, I think Mr. Panos supplementarist, yes, ask a question. So in what way is this method different than the other angio based FFR Simpson like QFR or FFR angios? So how does the CFD algorithm perform in patients with impaired microcirculation function, such as diabetics? So that's a very good question. I think it's more also from the engineer side. Bob, do you like to take this question, or I can?
Yeah, can you hear me?
Yes, please.
Just now the signal is not so good. Okay, for the question from panels, first one is based on compared with QFR, FFR angio. Okay, the first one compared with the QFR, as we know, CFFR, we can get the aortic pressure from the transducer directly. That means the aortic pressure is the pressure at the time of the angiography. That means when we use the angiography to make the 3D construction and calculate the CFFR, we can use the PA when the doctor gets the angiograms. So they are consistent. For the QFR, there is no accurate PA input, just they use some historical data. That means, okay, they use the age, the male, something like that. When if some special case, they couldn't identify the special one. So they, in mostly 60 or to 70%, they can get the good answer. But for some critical zone disease, stenosis, it's not a good choice with the QFR. For the FFR angio, it's the use formula, not a great CFD based on the Navistock formula. Please, Nick, please close the microphone. About current.
Yeah. Yes. Panels. I think that and that's a very good question because it really identified it. the difference between the our CFD algorithm, the RingMed KFR and the QFR, FFR, NGO from Medis and Guesswork. The thing is that we use different input, like Bob just said, that we also use the real-time sensors input. So by the study is summarized, for example, like a favor to Europe and favor to China, I think that the highest accuracy achieved by the Medis is the 91%. And also from the FAST trial that conducted by Bill Fearon in the FAST is from the Guesswork is 92% accuracy. So so far that the RingMed have achieved the highest accuracy thanks to the CFD algorithm. The second thing about the microcirculation, microcirculatory function for the different study, like the diabetes patients, Mayo Bridge patients, we have made some comparison in our following study, especially about the microcirculation physiologist. So yeah, we can share more with you later on. But for the CAFFR, I think that we also make some side study. There's a very slightly different. The p-value is below the 0.05.
Okay, great. Thank you very much. Yep, thank you.
Okay, thank you, Panos. So I move on to another question. So Frederick Marty asked, do you need additional people in the CAS lab to manage the case with the team and make the measurements? I think that would be Professor Liu. You might be the better person to answer this one. Because
yes, I think if we have some like operation nurse or technician or fellow can do the management, but anyway they have to train before they use the software, so it's quite easy and very quick.
Mm-hmm. Yes, just some additional implement is that actually in China, I think that usually the technician that can assist the cardiologist to conduct this calculation. But I know that in many countries, the doctors are required to do all the physiology calculation. So in that case, we also have a fast protocol that to help the doctors to do it alone. So that will be two protocol. One is done and instructed by the cardiologist. Another one is done solely by the cardiologist. Does that make sense, Mr. Marty? Yes. Okay, so if that's okay, I will move on to Hoshino-san's question. That so can you estimate it FFR in RCA Austrian lesion? Bob?
Yes, thank you for
Yeah.
a good presentation. I want to ask one question. Could this system, CAFFR, could estimate accurately FFR in RCA Austrian region? Because QFR system couldn't estimate QFR value in RCA Austrian region. So how was the CFFR system?
Mm-hmm. Professor Liu?
Yes, my answer to this question is yes, because we can we can use CFFR to measure the osteo RCA lesion, because we can get the aorta pressure in the real time. So yes, the answer is yes.
Thank you. And furthermore, I have one more question. Okay.
Please.
Yeah. Okay.
Okay. Just like QFR system, could we retrospectively analysis CFFR in laboratory? Because we need aortic pressure, so we can only get CFFR in cath lab or not.
Yes, we use during the procedure. You if you want to measure the CFR, and you injection with the contrast, and with the at least two obligate of angiogram have different view of the lesion you want to investigate. So after very good injection of contrast, you can have the very good data, and you can get the CFR value just in the CAS lab. Very quick and very convenient.
So we can retrospectively. Sorry.
Yeah, we did some.
You can yeah.
Yeah,
Okay.
we did
you
some.
can, yeah.
Sorry,
Yeah.
please.
You can, please. Yes.
Yeah.
Please.
So before the FLASH study, that we did some retrospective studies, and also by the design of the study, we have to do the retrospective calculation on the core labs. We call core labs. So we summarize all the real-time pressures curves. So we record it, and then we combine it together in the core lab and to do the checkup study. So the aortic pressure, especially the real-time one, is the very key input for our Simpson, for the CFD algorithm. So yes, we can do the retrospective. The accuracy is not as good as the study in the FLASH that is sorting, but it can be done. But it is not the way that how it is used. Yeah. Do it make sense? Sorry. Does that solve your problem? I understand that for many, we have some requests from many doctors. They want to do some retrospective study, use our new algorithm, and want to compare with the different Simpson. But the thing is that we have our Simpson to be approved by the protocol is based on the real-time curve, the aortic pressure curves. So the accuracy might be different. So because of the algorithm. Yeah.
Thank you.
Thank you. Thank you. So Professor Liu is in the study of the FLASH, and we are actually conducting a post-market study, the FLASH 2. So is anybody have any question addressing to Professor Liu? So he's the real expert in the field. Huh? Yes. So I have the read out all the questions that's showing in the chat box. So Barut, does that answer your question already? Hi everyone. Okay, if that's all, then then I have here. Thank everybody that who joined our webinar this time, and thank you Professor Liu to give us this a splendid presentation for the study and also for the use in everyday clinical site, and also thank you for this good question and a good discussion about this new technology. We can wait that to join forces to conduct more study with you all, and so that to launch more use of these physiologies. Because like Professor Liu said, for years FFR have proved its utilities in the cath labs, but it is underused for many reasons. I hope that the launch of the FLASH Angio can really help the doctors and the medical society. Okay, so thank you all. Thank you everybody, and very good presentation. So yeah, thank you. Yes, please before the end, please conduct the feedbacks to us. Write down the feedback for us, and we really thank Professor Liu again. Thank you.
Thank you.
Thank you. Thank you everybody.
A good day. Bye bye. Bye bye.
Good day. See you. See you, everybody.
See you.
Bye bye.
Thanks very much.
Thank you.
Thank you.
Thank you all. Thank you.